Okay, in this video we're looking at angle pairs formed by transversals. So there's a couple of vocab we need to make sure we understand before we get started. Parallel lines are two lines that do not intersect and are coplanar. Remember, coplanar means they're in the same plane. So parallel lines are two lines that are in the same plane but do not intersect. Skew lines are what we call lines that are not in the same plane and do not intersect. So their definition is two lines that do not intersect and are not coplanar. And then we have parallel planes. That's two planes that do not intersect. And then a transversal. A transversal is a line that intersects two or more points. So in this concept, we're looking at identifying angle pairs formed by transversals. Transversal is just a line that intersects at two or more points. So here's a picture to help us understand a few of those things, a few of these vocabs. Notice here it tells us lines M and N are parallel lines. The notation, sorry, it's hard to see there. M is parallel to line N. So notice here the little arrows show that these two lines are parallel to each other. Lines M and K are skew. So notice M is in plane T and K is in a plane we can't see here, but it intersects plane T, but it's not in plane T. So because those two lines are not on the same plane and they do not intersect, they are called skew lines. Planes T and U are parallel lines. So notice these two planes, they don't intersect each other, so they are parallel lines. And lastly, line K and N are intersecting lines. So there's a plane we can't see, but it contains them. We know that anytime we have two lines that are intersecting, there exists a plane that contains those two lines, or those two lines establish a plane. Okay, there's a couple of postulates we need to look at as well. The first postulate is the parallel postulate, and it says if there is a line and a point not on a line, then there is exactly one line through the point parallel to the given line. So here's an example. Point P is not on line L, therefore there's only one line that's parallel to line L that goes through point P. This is one of the fundamental postulates of Euclidean geometry, which is what we study in high school, Euclidean geometry. Without this postulate, some of the other rules we look at don't apply. So it's important that we understand this. Similarly, the perpendicular postulate says if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So an example, here's line L. P again is not on point L. So because P is not on point L, there exists only one line that's perpendicular to line L that passes through point P. So we're going to look at some examples of how we would use these. So these ask us to think of each segment in the diagram as part of a line, and which lines or planes contain points B and appear to fit the description. So as you're going through these, you may find some answers that fit the description but don't go through point B. We're just going to look at the ones that go through point B. So number one says lines skew to line FG. Well, here's line FG. So any line that's not in the same plane. Well, FG is actually on a corner, so it's on two different planes. It's on this plane across the top, which is plane AFG. It's also on this plane in the back, which is plane EFH, or plane FGH. So we need to pick a line that's on neither of those planes, and it's parallel, or sorry, not parallel, it's skew. That means it does not intersect this line. So an example, BC is not on either of those two planes, and it does not intersect line FG. So BC is an example. Okay, number two, lines perpendicular to FG. So FG is this line here, a line perpendicular that again passes through point B. Well, here we have a right angle marked, so we know that line BG is perpendicular. Alright, number 3 asks us to find lines parallel to FG. Again, FG is the same line back here. So a parallel line is a line in the same plane but does not intersect. So line AB is an example of a parallel line. Line EH is also a parallel line, but again, remember we're looking for lines or planes that go through point B. So EH does not go through point B. But I just wanted to show you we have two different planes line FG is in, so we have two different planes we could pick lines parallel from. Alright, lastly, it asks us to find plane or plane parallel to plane FGH. So FGH is here in the back. May be helpful if we shade that in to see. Here's the plane we're talking about. So we're looking for a plane parallel to that. That's a plane that does not intersect. Well, pretty much all the sides of this shape intersect it except this one in the front. This one in the front is a plane. Its name would be plane ABC, or we could use any of these three letters. ADC, BCD, etc. Alright, number 5 asks us to name a pair of parallel lines. So we're looking at a new diagram. We use these arrows to help us see parallel lines. So this is saying that line WX is parallel to line YZ. So that's an answer. We also could have said line UV is parallel to line OR. Those are both answers in this example. Number 6 asks us to name a pair of perpendicular lines. Well, here's a right angle given to us. So we know that line UN is perpendicular to line SN, or we could say ST. Remember, lines we can name with any 2 points. So ST would also be an appropriate name, or NT, either of those would work. And lastly, it asks us to determine if line WX is parallel to line QR. So if we look, WX is here, QR is here. We can tell they are not parallel because they intersect at this point right here. Because they intersect, that means they are on the same plane, but they cannot be parallel because they intersect. Our definition of parallel was lines that do not intersect.